Hey, welcome back to Made of Wires. Thanks for watching. We're going to decompile Castlevania Symphony of the Night. I'm going to do some work to get my workspace working again. Metro Wrap was merged in, and a bunch of new build tools. Not familiar with some of the other changes that were made. But we're back, and you can go to symphony.z.dev if you're interested in the project. There's a link to Discord and a link to GitHub. And that's where we're going to get into. A little shorter stream today, probably. Hey, Romy. Good to have you. Let's get right into it. So when we left, I was working on a PSP function that I'd already started the US version of, but wasn't real happy with where that was going. So I thought I'd start working on the PSP and see if we could make more progress there. And we were about 60%. There's 3-ish functions left in the RBO0 overlay. So we're going to do just a few things here to clean up while I get myself reacquainted with this. And we'll see what there is to see. So a lot of times these pass-through assignments, if you see things out of order, that may be what that is. And there'll be extra masking and other things up there. I'm not going to worry about registers quite yet. We have a long way to go. Same with stack pointers. A bit to go before that. Let's look at 50. No. This looks out of order, but not in the way that I expected. Oh, it looks like it's because of stack pointers. Not too concerned with that yet. I'm just going to keep going. Again, these fields are out of order, so I'm going to assume that they are pass-through assignments since the values are the same. And you'll often see the extra mask there in the assignment that caused that as well. So looks like this priority is just a plus, maybe a plus equals 1, we'll see. Let's try a plus equals 1 and see if that changes things. Okay. Oh, it's not plus equals, it's self priority. Might be Z priority is the name for that field. Hey Trevor, good to have you. Thank you, thank you. If I can type, I can get things approximately right. Again, stack pointer stuff here. Not going to worry about that. Anything with the SP register and an offset related to that register, I'm going to ignore for now. Don't do that. We'll go here. I'm going to get rid of some of these casts. The sign extension typically means that this value is coming in as a signed value. I think all of these look fine, but there's some additional sign extensions here. It could be because the value of that is known. It could be these here. These may be signed 16s. Let's look at how that is going. Yeah, possibly V0_3 is a signed 16. It already is. So not quite sure what's going on there yet, but there may be something. It actually might not be a signed 16. It could be a signed 32 actually, and M2C just proactively did that. And just if you're new or haven't watched the stream before, what we're doing is decompiling parts of Symphony of the Night. This is the Grant Ralph Sifa boss fight. Here we have a timer. Timers are usually signed, so I'm going to assume that this is signed as well. We're going to look for anything I like doing these all at once. Anything with this unsigned 16. We're going to change that to a signed 16 and do a not minus minus there. For our timer decrement, make sure that it's going to the signed version of that field. Hey, buyer. Thank you, thank you. I did want to provide a brief update. I may not stream all week, definitely not next week. I have some personal things that I'm attending to that are taking up a lot of my time. Hey Orphus, yeah, it has been a while. It's going pretty good. We're making progress. So it looks like down here, that looks correct. I'm going to come back to that in a second. So this was put up as the default case because case 1 fell through to that. Case 0, we need to see if it's a fall through. It is a fall through, so we don't have to worry about that. I was looking at these though. Is there any? Oh, we found all the timers, so that's fine. So this particular function, we're basically falling through to step 1, and we're going to keep running step 1 for 64 frames. And then we'll move on to step 2, which is where this is destroyed. I guess once it gets to a particular place, whatever this thing is that we're looking at. Orphus flow. You're saying words that I don't want to hear. As far as I know, yes, there are people working on AI agents. I don't for this, mainly due to existing legal precedent in the US. I have a significant and I think well-founded fear that using AI for decompilation would put you in the position of copyright infringement, where doing it manually keeps you pretty safe from that. And so I don't want to give any suspicion of this being automated in any way, or the law says a mechanical transformation. Once this becomes a mechanical transformation, then it's no longer something I own, and it's something Konami owns. And if I'm doing something with something Konami owns, I think what's happening here, I'm going to make this aside, I think this is being assigned before it's being used as a parameter. I think that's what's happening. And I think that is a signed 16. So there's a lot of legal precedent basically for people getting in trouble for mechanical transformations of things, and a lot of current legal battles related to generative AI. And so I just don't want to get into that. Yeah, there is. And until there's lawsuits and, precedent, and precedent is pretty rare, and especially with people who don't have necessarily the resources to fight a lawsuit. So, like, imagine some lawyers were sent after your friendly neighborhood decompiler. Oh, interesting. These look like they are unsigned. Thought they were going to be signed. Should that happen, your friendly neighborhood decompiler is going to fold almost immediately. because Konami has lots of money for lawyers, and your friendly neighborhood decompiler has 0 money for lawyers. And because they fold immediately, there will never be court precedent. And it would take, say Iga or, who's the Metal Gear guy? I can't think of his name at the moment. Say either of them decided that they were going to... What is... Oh, this is the params, sorry. Decompile their previous works for one reason or another. They found some value in that. Then they might have the resources to fight that. These look like signed 16s. And so unfortunately, oh, that's not what I wanted. Unfortunately, unless somebody with deep pockets gets in the middle of it, I don't know if we'll ever know. The issues going on right now, though, are with the big players, basically. They pull in all of this information. A lot of it is copywritten. And then they are building generative AI images off of that. And so are they committing copyright offenses with their generative AI? And they're not letting that go to court either. They're settling those out of court. Kojima, thank you, Vire. Even then, I mean, how much of your time do you really want to dedicate to that? So I'm going to call this var S4 pause X. So what we're doing is basically calculating an angle, and then we're using sine and cosine to give us the horizontal distance and the vertical distance for that angle, so we can adjust. Yeah, I've read some of the things that others have done. So there's the Decomp Discord. I know people. I'm pretty sure there's a whole channel there where people are talking about it, and it's very effective. And unfortunately, the effectiveness is what I think is going to be a hindrance. I don't know a better way to put it, really. So some of this I think is largely stack related. So let's try to slim down our variables and see what we can do. I'm gonna go anything related to this offset 4 here. I'm gonna call that pause X. We're gonna go var S4. And maybe one day they'll find that everything is fine and nothing is wrong, and then I'll do it. But until that day happens, I would not risk any of my own resources to prove that. I will volunteer my time to decompile, but I will not attempt to fight any corporations over it. Temp these 0. I think I have an angle value already. This one might be a 32-bit. It looks like I have a few more of these that I have to fix, though, so let me do that. I'm not saying that I agree with any of those or anything really one way or another, just that is the legal risk that I am trying to avoid. And others live in different countries. They live in different jurisdictions, and they don't maybe have the same concerns. And that's fine. Everybody has to kind of have their own tolerance, their own risk tolerance. And I'm not a lawyer, not your lawyer, kind of thing. I think we have a divide by 2 here. Shift by 1 is the same as divide by 2, and then often these checks, additional checks here, are the test to see if there was an overflow or other error that was done by that. So we need to see where this temp var A0 is being used. This looks like it might be a additional variable. And so I'm going to say that this is, we're going to make 2 new ones. I'm going to make these sine 32 because I don't know any better yet. We're going to have offset X and offset Y in addition to pos X and pos Y. I'm going to say that this is offset X. The casting of a sine 16 probably indicates that it is a sine 16 value. And then I can get rid of all of this. Same thing here. We're basically doing the same thing. It's eventually going into var B1. And it's possible that this should be just resetting pos X. I'm not sure though. So I'm gonna. All right, I already had pos X or offset X and offset Y. Those are 32-bit already, so we'll leave them like that. And I'm going to try to clean up the rest of this as well. No, I screwed up. Did I add X to Y somewhere? That's a screw up if I did that. That should be... I must have gotten that backwards. We'll see. It'll work out in the end. Thank you for pointing it out, though. I appreciate it. Don't necessarily have the best headspace at the moment. I'm gonna look for this temp S6 and see where it's used. We may be able to figure out what variable that is. Most of the time, I might be able to just get rid of actually the _2 and use the same temp S6 there. Let's do that. And we'll give it a name later. Same with temp S5. Those are more than likely the same variable. We just don't know what that variable is quite yet, and we'll give it a useful name at some point in the future. It's getting cast to sine 32, which does make it seem like that legitimately will be a sine 32. I like to get rid of casts along the way just because they're noisy. Let's get rid of the second. So we have S5 and S6. We'll pull those up and get rid of these other declarations. It's actually probably something that I should be better at doing. It's like I didn't do my parens right. As we start pulling these down, though, we should continue to see better and better matches. So we have something wrong here. We're doing a sine extension. So I think I have pos x potentially as a sine 32, and that indicates that it's, or sine 16, I mean, should be a sine 32. We should get rid of a lot of those, and that helped quite a bit. Still do have a little too much on the stack. Prim index is going to be a thing. Prim index, I think, is usually a sine 32, though. Are we getting SCHs? Yeah, we are. And I'm guessing angle is actually going to be a sine 32 as well. Let's look at this, 84.87. That's slightly better, so yeah. Let's go with that. I'm going to go and try to clear out the rest of these variables if we can. Temp S7 probably is a real variable, but I think it's going to be the angle variable, and we already have that in place. So we can get rid of that. Let's look at 74. We are pulling this into a variable. We're actually pulling it into the same S7 register, so we'll use angle again, since that looked like S7. Thank you, Orpheus. Appreciate it. Let's go down to 135. Orpheus pointed out that I'm switching X's and Y's. Interesting. I must have gotten I probably screwed that up just about everywhere then. I thought I did it based on the highlighted variable. Maybe the other one. We'll see. We'll see. We'll get proven right or wrong one way or the other. See how many temp v zeros we have. I'm going to go with angle here as well. Are we, okay, 85. So V0 is the return register. The return value gets put there, and so then we're assigning that to S7. The sine extension indicates that whatever we're assigning it to actually is a 16-bit value, or normalized angles coming as a 16-bit value, but I think it's the variable. And then we are promoting that 16-bit value back to a 32-bit value to use as A0. And the result of that arc cosine call, nope, I wanted to know if normalized angle, this one, is that going back into S7? It is. So, and I was incorrect. I think I just changed that to a sine 32. I'm going to move it back to a sine 16. And that helped a lot. That's actually starting to shape up and look like a real function. It's almost a real boy now. Okay, so here, what we're saying is that we're pointing to a 0.16s are 32-bit. Oh, duh. It should be 1. And let's just do a minus there. 0.16s point to a 32-bit value, so when you do pointer arithmetic, you have to multiply everything by whatever the width of that struct would be. And apologies for jumping around a little bit. This looks like it should be a plus equals. but we're dealing with words. I don't know why this came back as a... And this is not quite right. Oh, duh. So what probably is happening here, we'll see if that's the case, is that this is re-specified. No, I'm wrong. Are we treating this as a pointer? Oh, this assignment to pause X. Possibly these are coming first. I don't know why. Sorry. This looks like a reference. So we're taking S1. Why would we get a reference to that? Okay, so I'm gonna just try it, see if this is Sign 16 pointers. It's possible that it is a point 16, so we could try that. We could try reusing var S1. It is going into S1, so I think that's fair. So let's try that. It's a little bizarre. So we're gonna say var S1 is a reference to this offset. And we're going to cast it as a point 16 because we don't have that in the illegal placeholder. Struct point 16. And that gives us the correct instructions there. So we take the original offset of self, and then we're adding the additional offset of this field in the struct. And that's what gives us those instructions. And so now we've updated a pointer rather than read what the pointer value is. And then we're going to do assignment to that pointer instead of directly to the fields in the struct. And then why are we reading it back? So we're doing that again. I don't know why. Because we literally just did that. And now we're reading these into local variables, but we've missed something along the way. We're loading, it looks like self, and then offset 17. That's this prim. So we're doing that twice as well. We have extra variables, so this is overflowing onto the stack. Not too worried about that at the moment. This is bizarre. That's the best way I could put it. So then we're going to S1 here. And we're going to use that as a array, basically. And again, we're loading some of that from the stack. Are we putting these in? S3, S6. So those might be going into additional variables. We'll see. Temp S6 and temp S5 down here, I think might already be assigned to offset X and offset Y. Let's look down there and see. Are those S6? No, that's S4 and S5, I'm guessing. Yeah. Sorry, S4 and S3. So let's mark those up here. And while I'm up here, we'll get back to that. Let's take this and look at the PlayStation version. See where our issue is. Okay, let's get to the initialize entity call. Going to be an animate entity frame. All right, this is 98%. So yeah, we are on the right track. Not quite there, but we're getting there. A little strange to start with the PSP, but what are you going to do? Okay, we're going to keep going. That's what we're going to do. We have the right stack size now, which is kind of crazy because we sell a lot of extra VARs. Usually this has been angle, so I'm going to keep it. I'm going to use angle here as well. It might not be, but we'll figure that out. Actually, that looked really good, right? That did look much better. Any other temp V0s? Nope. Temp V0, V0 register is used for return values, but it's also used when the value isn't necessarily in a variable. All the temp V1s go away. Gone. All right, so we might still have too many variables. We have one extra set of X's and Y's. They may or may not be real. Well, thank you. All right. So I did say that I think that this is going to be D is 13. We're still having some stack issues here. Let's look at the top. I think I have the right stack size, 40. So it's 64 bytes on the stack. That's fine. But we still have a few things spilling over. Some of that may be due to variables. Some of it may be due to lots of different things. So I think it's the time of the day. I should have like a Bill Nye style transition here where we talk about tracing registers and seeing which registers are involved. Mapping the variable to the register. And let's do that by starting with prim index, which is where we are. Prim index eventually is going to be S8. And what I will do is right now it's falling to the stack. And so ultimately what I want to see is, are we always using S8 in the same way as on both sides? But because it's on the stack right now, I can't do that. So we're gonna have to come back when that's no longer on the stack. So let's move on to S4, hopefully. Line 43. No variable there. Let's see. I should be S2. Typically it is S2 in both cases. It is S2, so we just want to go scroll through, make sure on both sides S2 is always being used the same way. And if there's any difference, and we can reason about why that difference might be made, good. And if we can't reason about why it's made, then we change it. Here we go, 158 possibly. So I think that this is being used ephemerally, which means these values aren't actually getting assigned to I. The compiler just knows that I is not going to be used again, and so it assigns them. I think. Yeah, as part of the pass-through assignments. So I think that's fine. I think S2 is fine. And I don't know why it's the convention, but it's pretty common to see S2 as the register that's assigned to the I variable for loops. I would have thought that would be more, I guess, random, but it's not. All right, so the next thing we have is S0. And S0 is used a bit, and then I think for not any purposes that we care about, but then it's used as prim, and it's going to be used as prim throughout. Should check for less than equals as well. And so we just want to make sure again that those are all used the same way. And it does look consistent. So no concerns. And we're going to mark that as S0. Player. And 69. Player goes to the stack, and it goes to same place on the stack in both functions. And I doubt it's going to be referenced outside of that, so that's fine. Might this not be in a variable? Let's try it. Can we get this to work without a variable? No. Until it works fine here, so let's keep that while we're here. Look at line 70. I think I have S7 as angle already. I don't have it marked. So here we'll just mark this as 3C SP. So registers are the same until they're not. So when they're being used as variables, we want to see them looking like they're approximately the same. So we don't have the right register right now allocated. 110. Let's look at that. So it does look like these may be happening outside and being assigned to S5 and S6. Okay, and that ended up looking pretty good. But so now our registers got all messed up. Now what was S3 is now S5. It looks like. And we have our call to RTAN. The value is stored and then subtracted as a second step. And now we're back to S3 as that variable, but that's all working fine. So 110, let's go up 1. It looks like pos X is getting spilled to the stack, and pos X should be S4. I think, yeah, roaming, I think that's the same as what I got. Yeah. Good minds think alike. Great minds. How about that? All right, so S4 right now is my stack offset 34. So we need to figure out what that is, and if I can get that from spilling off the stack. That's on 117. It looks like pos X. Because S6 is fine. S6 is ours. So pos X should be S4, but here I have offset X as S4. So that tells us something nice. So 117. Here, this pos X value should be S4. And that will I think that's fine. That should start collapsing. So it looks like offset X and pos X may be the same thing. That should start collapsing this. I'm going to stick with pos X, I think, and get rid of offset X, and then we can go back and... Can I do that? Yeah, I think I can. Let's look here before I do that. 125. This is going into S. That result ultimately is going to S4, which is, yeah, pos X. So we're going to get rid of offset X, and those are all going to be pos X. And we're going to get rid of offset Y, and those are all going to be pos Y. And that should, hopefully that's what was missing. We should see less spill to the stack now. I don't see any, except for here on line 120. The +4 is not there. Oh, it is there. Oh, this is interesting. So this is actually, RS1 starts at, we see it up here. It starts at 4. But it's not that. This is just RS1 plus equals 4. Plus equals 1 plus plus. There we go. And I think like up here. No, up here I still want to pull these out really bad. I still want to pull these out. So we're getting the subtraction, and that's getting stored into S5. That S5 is temp S5, and that's fine. Nothing's wrong. Everything's fine. Temp S6 is going to equal this. That's looking better. And then like above, we're going to do angle minus equals. Oh my goodness. We're almost there. We're so close. 118, I have it backwards. Oh, we're getting real close. Getting it wrong. I'm gonna stop what I'm doing. I think I'm screwing myself over a bit. I'm gonna go top to bottom and check things out along the way. Temp S5 and Temp S6 may be backwards in some cases. Prim index is, oh, it's S5, but that can change. Let's, yeah, that's fine. I'm fine. Nothing's wrong. When we figure out whatever last thing there is, that should resolve itself. 82, we want S6 and we have S4. 82, so that's, let's highlight all those. I think this will do it. Okay, those all match. And now those all match. Ooh, they don't all match. Oh, they do match. Odd that these are backwards looking. That's okay. We change their order. Sometimes they go in the right order. That's all it was. So temp S6, I'm going to call offset X, now that we have that symbol free again. And temp S5, I'm going to call offset Y. And just for fun, let's see if that's working on the PlayStation. Okay, symbol names are wrong. Everything else looks mostly okay. Oop, one issue here, and yeah, I think I have that backwards some places down here, so let's go find where that is. We might actually get a perfect match on this, which would be a little surprising to me, but stranger things have happened. One of the odd things about the Rust programming language is you can have trailing commas in your arguments. That's weird to me. Weird and ugly. I don't like it. I think that might have been it. So we have two lines here, just symbol name differences, because we're using a struct. So it's calculating the offset versus having a specific symbol name. I think those are 5 each though, and we have 20 altogether, so I think there's going to be one more. Maybe they're 10. Nope. Here we go. I was right. These are backwards as well. And that makes sense. And so we have our 10, so that's it. Yeah, you get better with practice. Literally the reason I started this stream was to force myself to get better and practice. You'll learn a lot along the way. I'm not saying stream it, but because then you're competing with me. I'm kidding. You do what you want. Yeah, the things that I need to get better in life are anxiety of being in public and anything technical I'm happy doing. And so this kind of fulfills both of those roles. And so we did it. So this one should be able to slot right in. I gotta get the right function name here. But this will bring us to 2. I think what I'm gonna do, and I'll go over this quickly, I think I'm gonna get the permuter going. So I mentioned the Metro Wrap stuff last week, and that's merged in now. One of the things that I wasn't even thinking about, but ended up being a huge benefit as well, the way the permuter works is it will come through and make small changes in your C code and tell you if it is closer or further away. And every time it does that, it has to call the compiler again and recompile, and it does that through MWCC gap or Metro Wrap, whatever MetroWorks wrapper you're using. But Metro Wrap is, for a normal compile, about 40% faster. And so in the span of a minute, when I was testing over the weekend, MWCC gap, I got 3,300-ish permutations in a minute versus 5,400 for Metro Wrap. That's pretty sweet. Who doesn't love when things get faster? Python coders, that's who. Oh. Can't dig at Python coders enough. I'm kidding. If you like Python, good for you. The draw mode field has been renamed to blend mode. And now that works, and let's find our ESP version of that. We'll do the same thing there. I really need to fix my context. We'll find it eventually. And the other thing I haven't done yet in any of this is fix any of the entity extensions. We have unfortunately not a very good way to do that outside of decomp.me, so we'll probably go back to decomp.me and look up as many of these scratches as we can and start building those entity extensions. Recompiling is faster now, but still not as fast as doing a single file with a smaller context here. I'm going to grab these declarations. And we're going to save all this. And we're looking for this CC220. Yeah, I'm when I say going out in public, I mean I don't like talking to people I don't know. Just general social anxiety that I'm sure a lot of introverts go through. Nothing wrong with my immediate community or anything. It's a general fear of people. Let's try that, and that one works as well. Awesome. So I'm going to do a diff here. I know symbols are going to be different. We're going to have the PSP version on the left. Let's do the Vim diff. That's nice and more graphical than just a line diff. It's going to yell at me because these are open already. And don't worry about... I'll get rid of this. Oh, that's re-rolling. Yep. There you go. Symbol names are going to be different, and that's fine. So far, that's all I see in red. It looks like some comments were fixed. Those are the comments related to registers that I literally just did. Get rid of these comments one here. Oh. I should have /D, right? Yeah, I do. DJ, yes, on YouTube, could you give a short explanation of what decompiling this game means and what will be capable from it? So what we're wanting to do is write C code that compiles to exactly the same machine code that was found on the disk. And so we have the machine code and can then attempt to write C that just happens to do exactly the same, or compile to exactly the same thing. So these files are actually, they look good. And so what we get at the start is a bunch of these include ASM lines in our C files, and those go through and bring in disassembled machine code that came from the disk. And then one piece at a time, one function at a time, we translate that into C. And once we have C code, this was actually the original version of Symphony of the Night was compiled with GCC, an older version of GCC, but we have code that's effectively still compatible with any modern compiler. It's an older version of C, but modern compilers still understand that just fine. And so people can do a couple things. They can make mods to the game, and there's been a few. So one of the mods that was done by the leader of this project was taking the PSP version of Maria and putting her in the PlayStation version of the game, in a way, a playable version that wasn't originally there. Some people are interested in porting it, so building a PlayStation compatibility layer with, say, SDL or some other gaming library, so that you could play this on the PC, and it would be a native version for the PC, built with the same code. And that's effectively that shim layer. That's effectively how the Xbox 360 and the PSP version were made anyway. So that's an interest. We found a bunch of stuff along the way about structures and other information. And that's been used by the randomizer community. So the randomizer community has been doing all this by just looking at the bits and bytes on disk. And now we have code, and we can understand how some of those data structures work. That's kind of a short example. I am a believer in God and the Bible as well, and I do ask for peace in situations where I know that I'm going to have to do things that are uncomfortable. And something I'm working through and trying to get better at daily. That's all I'm going to do today. Appreciate everybody showing up. Love the username, by the way. I only use physical media. I love it. My son's birthday was not that long ago, and huge sports fan, more of a sports fan than I ever have been. And he wanted Madden 26, and it hurt me so much. But I had the... Do I get him Madden 26? I was going to get him the Switch version, Switch 2 version. The Switch 2, like, dummy cartridge that then he has to plug in, even though the game isn't even there. Or do I just get him a download, which is like a terrible thing. I ended up getting him the key card. I don't know if that was the right choice. It hurts so much. It hurts so much to buy a game key card. What a terrible thing. What a terrible thing. Anyway, go to so.z.dev to learn more about the project. I don't know if I'm going to be back this week or not, and definitely not next week. We'll see. Craziness in the personal life. So when I'm back, I'm back. Otherwise, I'll talk to y'all later. Appreciate all the new people showing up. Really enjoyed having you here. Adios.